Greetings, judges. We are St. John's Institution, bringing to you an outstanding breakthrough in medical technologies incorporating AI. We bring you the OxyPulse detection system, also known as the OPDS.
Ladies and gentlemen, the cardiovascular disease or the CVDs are the leading cause of death globally, accounting for 17.9 million of deaths annually according to WHO, which is the World Health Organization. Early detection and intervention significantly improve survival rates, yet access to reliable diagnostic tools remains limited in low resources setting and rural areas. This is why we created the OxyPulse detection system. The OxyPulse detection system, OPDS, uses real-time images of ECG and heart rate data to detect anomalies such as the cardiovascular irregularities. The OPDS integrates artificial intelligence AI with pulse oximetry and ECG sensors to create a comprehensive monitoring system.
So now moving on to what our product is designed to do. Our product is designed to monitor and record heart rate data. Furthermore, we utilize AI algorithms to analyze the data in real time, identifying abnormalities such as irregular heart rhythms, ST segment deviations, and abnormal heart rate. Moreover, we provide alerts to users and healthcare providers via a mobile application. Last but not least, we store and analyze historical data for trend analysis and predictive insights.
Ladies and gentlemen, first we start on our components, on the exterior components and the mental of our project here. So first of all, we are using an Arduino Uno to monitor and correlate all the systems in this device together, which is the heart rate modules, ESP8266, LCD module, and our Oxy sensor. So currently the ESP8266 will transfer data gathered from a heart rate module, which are from these healthy pads, and they will send this data to our apps where doctors can monitor them on their phone. Furthermore, we are also putting in a display screen where the data will be instantly transferred here for the doctors to monitor on the spot. We are also using a power bank to power our prototype module here. So, when a person puts their thumb on our Oxy sensor, the data will be retrieved from our sensor and transferred onto the device. Here, we can get a very accurate reading on how and what are the data from the person. Furthermore, you can also detect the heart rate, so the health pads would not be necessary to be intervented here. So when the health pad data will be transferred to the app, in the app is a way where we will use AI to integrate and identify whether the readings are arrhythmia or is it normal. Let's move on to the next part. Ladies and gentlemen, so this is our code to transfer our data from the ECG module to ThinkSpeak. So our code is just to transfer data, is very basic and simple. So once our data has been transferred to ThinkSpeak, the data here will be transferred into a graph to track and plot ECG values. So once it plots ECG values, now this data can be transferred to our app. So in our app, we have a basic system where users log in, and login systems will basically have the doctors have their authorization, so no one other than them is authorized and can only be logged into the system. So once they go in the system, they have their own screen and displays output. So this is how our app look in real terms. You see the graph will be displayed onto the screen, and they also have the interface to go back to login and to their system. So basically this is how we track our app and get our data to our app. Ladies and gentlemen, basically this is for our part of testing of our AI. So we created an AI to detect arrhythmia and normal heartbeats. So from here you can see this clearly an arrhythmia heartbeat because of the spike is too short. Therefore you can know there's a 75% chance here of it being arrhythmia. So this is a classification result, but when you go to our model testing, you see how it works. We have found out you have 86.67% accuracy to knowing how we have tested this the whole thing about. So we have currently used hundreds of samples to make sure that we can get a quite accurate testing. But do note this is in very early stages, therefore we are still trying to improve our AI here. So moving on to our live testing, you can see if I put in one of my heartbeats over here, you can clearly say it's normal heartbeat.
Judges, we believe that the OPDS can not only change the way how we perceive and maintain our patients in our modern world science. So, basically, the OPDS could be one of the ways that we help doctors achieve goals that could not be achieved previously. But now with AI, anything is possible. Therefore, judges, I urge you to pick the OPDS.